Alright, good morning everyone and welcome back. Today's lesson is going to be on trigonometry ratios of right angled triangles. And before we begin, let's just do a quick review of what we did last year. So firstly, we can see that we have a 90-degree angle in our triangle, which gives us a right triangle. And therefore, we can say that we have two angles, angle A and angle B, which are acute and complementary because they add up to 90 degrees. In addition, we also know that side C is called a hypotenuse because it is opposite of the right angle, which is angle C in this case. In addition, we also have this quick little mnemonic that we learned last year, SOHCAHTOA, and this helps us remember the three ratios that we learned last year, which is the sine, the cosine, and the tangent of an angle. So if I were to look at angle A for the moment, so angle A right here, the sine of this angle would be the opposite divided by the hypotenuse. And in this case, the opposite is A, and the hypotenuse is side C. So our ratio would be A divided by C. In addition, we have the cosine, which would be referring to the adjacent divided by the hypotenuse, which in this case would be B divided by C. And lastly, we have our tangent ratio, which is the opposite divided by the adjacent, and that would result in a ratio of A to B. So, today we are going to be learning the three new ratios in the trigonometric triangle right here, and those are very simply going to be the reciprocals of the ratios we already know. So this is going to give us the secant, cosecant, and cotangent of our angle. So secant is going to be found by taking the reciprocal of the cosine of our angle. So rather than doing the adjacent divided by the hypotenuse, we just take the reciprocal of that and we get C over B for the secant of A. For cosecant, we are just going to be inverting, so taking the reciprocal of sine. So rather than taking opposite divided by hypotenuse, we now take the hypotenuse and divide it by the opposite side, which gives us C over A in this case. And lastly, we have the cotangent of our angle A, which will be the adjacent divided by opposite because it is the reciprocal of the tangent. So that would result in B over A. So let's go directly into an example right now. So what I would like to do is find the sine of A, cosine of A, tangent of A, secant, cosecant, and cotangent of angle A. So looking at our triangle, we have something missing. So obviously, before I can begin, I must find that missing side. So obviously, what should come to mind is the Pythagorean theorem. And once we find side C, we realize that it is 5 units. Now that I have all three measures for the sides of my right angle triangle, I'm able to write all my ratios. So the first ratio that we're going to begin with is the sine of angle A. And sine, as we said, is opposite over hypotenuse, and in this case that would be 4 divided by 5. The next angle ratio that we are going to be looking at is cosine. So the cosine of A is the adjacent divided by the hypotenuse, which is 3 over 5. And we had the tangent of A, which is the opposite divided by the adjacent, 4 over 3. Now to get the next three, you can simply just invert the three that we already have, or you can actually remember them by the opposite of what we had in our SOHCAHTOA mnemonic. So secant of A, I said, is the reciprocal of cosine. So either you remember it as hypotenuse over adjacent, or you can just take the reciprocal of the cosine ratio. So we get 5 over 3. For the cosecant of A, we have hypotenuse divided by the opposite side, which gives us a ratio of 5 over 4. And lastly, we have our cotangent, which in this case refers to our adjacent divided by opposite, which is 3 over 4. So these ratios that we just found, these 6 ratios, can be written in terms of a fraction, or you can also write them in terms of a decimal. I honestly prefer the fractional form because it's more precise. Another useful ratio that we are going to be using is tan of A is equal to the sine of A divided by the cosine of A. Now, therefore, we are comparing the same angle for all three, and we have these three in a simple ratio. Now, because I've already introduced to you what the cotangent of angle A is, we should simply be able to invert sine and cosine to get a new ratio. And we do. So cotangent of A would be equivalent to taking the cosine of A and dividing it by the sine of A. So we'll come back to these useful ratios later on because they are going to help us with our trig circle. So certain remarkable angles are going to exist, and these are exact values. So for the present moment, I do not want any rounding for any of the problems that we are doing. We're always dealing with exact values. So if we are comparing the sine or cosine or tangent, we have certain remarkable angles, which they are 0, 30, 45, 60, and 90. These are going to be the angles that we need to memorize. We need to know this chart, because whenever we have problems like this one and we are asked to find the exact value, we cannot round. So if this were the question, find the exact values of x and y, how would I begin? And no calculator, by the way. So the first step in this case is to say that, well, the sine of 30 degrees is 1 over 2. And how did I know this? Well, because in that remarkable angles chart, I just looked under sine, and I followed 30 degrees, and I was able to figure out that the sine of 30 degrees is 1 over 2. So again, I need to memorize this chart. I need to know these ratios. So knowing that the sine of 30 is 1 over 2, I can also make a new ratio and say that the sine of 30 is also opposite over hypotenuse. So 1 over 2 would represent x over 10. And again, we're always looking at this 30-degree angle because this is the angle that we are concerned with. Therefore, simple cross multiplication, and I get x is equal to 5. So I solved for the exact value of 5 in this case. However, the y value may be a little bit more complicated. Now we have two options here. We can either use the Pythagorean theorem and we would get an answer that we would have to simplify, or we can do the same method that we just did, which is what I'm going to show you because I would like us to practice this method. So, as we know, using our chart, the cosine of 30 degrees is the root of 3 over 2. Now we also know what the cosine is in terms of ratios. Cosine is adjacent over hypotenuse. And in this case, the adjacent is y over 10. So, simple multiplication and division, and we get an answer of 5 root 3. Now this simplifies things for us because this is the exact answer. We don't want to give our answer in a decimal. We want to give it in terms of a radical. So that's all for today. So come back for our next lesson very soon.